Hi guys, welcome back to my channel. In this video, we are going to learn how to pre-process and load video to train a model. In previous videos, we conveyed how to pre-process and load image, and then we build a machine learning model. In this video, we are only focus how to pre-process and load video to try out machine learning model. Okay, the past 2 days I missed posting video because I had a fever and I couldn't speak without coughing every 5 minutes. That's why I couldn't post any videos. Sorry about that, guys. Okay, let's read and we will try how to pre-process and load videos. I'm exciting to do this video because in previous videos we are only pre-processed CSV files and images, but now we are facing a new thing that we are going to study about video preprocessing and loading, and we are modeling machine learning model for video generation, video analysis. Okay, first I want to minimize my video, otherwise I will forget that one. Wait. Okay, as usual I already run all the code blocks, and we will go through each one. Okay, first load video data. This tutorial demonstrates how to load and preprocess AVI video data using the UCF101 human action dataset. Once you have preprocessed the data, it can be used for such tasks as video classification or recognition, capturing or clustering. The original dataset contained realistic action videos collection from YouTube with 101 categories, including playing, shallow, brushing teeth, and applying eye makeup. You will learn how to load data from a zip file, read sequence of frame out of video files, visualize the video data, wrap the frame generator, tf data dot dataset. We studied tf dot data. In that they have, I think they have a new thing, dataset. Okay, we will see. In this video loading and pre-processing tutorial is the first part in a series of TensorFlow video tutorial. Here are the other three tutorials. Okay, we will see these three tutorials in upcoming videos. Now in this video we are only going to load and pre-process, I think. Also in final code block, I think. Yeah, final and code block we are modeling, but we are not seeing how the efficiency and those things, just modeling like that. Okay, so we will check what are these three things. Build the 3D CNN model for video classification. Note that this tutorial uses a 2 plus 1D CNN that decomposes the spatial and temporal aspect of 3D data. If we are using volumetric data such as MRI scan, consider using 3D CNN instead of 2 plus 1D CNN. I have no idea what's the difference between 3D CNN and 2 plus 1D CNN. We will see those things in next video when we are going when we are doing this build a CNN model for video classification. We will check what the difference and those things. And next one is MovieNet for streaming action recognition. Get familiar with the MovieNet model that are available on TF Hub. I think TF Hub is pre-trained model. Okay, we will see. Transfer learning Transfer learning for video classification with MovieNet. This tutorial explains how to use pre-trained video classification model trained on a different dataset with a UCF101 dataset. Okay, we will choose one of this. Oh, if we can, we will do all three things in upcoming videos. Okay, in this video, we are going to see other things. So we will continue this one. Begin by installing and importing some necessary libraries, including remote zip to inspect the content of a zip file, TQMD to user progress bar, OpenCV to process video files, and TensorFlow docs for embedding data in a Jupyter notebook. Okay. First, what we are doing is pip install. This one is dash u mean upgrade TensorFlow. This is a we are upgrading to TensorFlow's version greater than 2.1. Otherwise, the compatibility issue will come. That's why we are upgrading here. Next, what we are doing pip install. Here we are installing three libraries: remote zip, TQMD, OpenCV. Those three. We already see what the remote zip for inspecting the content of zip files, TQMD for progress bar, OpenCV to process video files. Okay, okay, they have some. Here we are, as usual, we are importing the things. In here, numpy np remote for remote zip, we are giving a short name as RZ. Okay, here what we are doing, import image IO. Some models display animation using image IO. Okay, in collab within the collab we don't have video player, so I think these libraries to visualize the videos. Using these libraries we are visualizing the videos. Okay, we will continue. Download a subset of the UCF101 dataset. The UCF101 dataset contains 101 categories of different action in a video, primarily used in action recognition. You will use a subset of these categories in this demo. Okay, this is the URL for that zip file. If we click, it will download that 101 categories, all videos. I'm not going to do that one. The above URL contains a zip file that, with the UCF101 dataset, create a function that uses the remote zip library to examine the contents of the zip file in the URL. Okay, first what we are doing is we are creating a function, then we can reuse it later. The argument is zip URL, which we here this URL. If we pass this URL to this function, it will return the files within that zip file. Here we are creating first files array, and after that using rz remote zip URL as zip. Okay, here okay, here we are contain using this file zip.info list. We will get all the information. A zip for we iterate every zip info, so it will get every zip info list, and here in the next every time if when we iteration we will append that file name to this array, so this array will uh, contain all the file names within that zip file, so it will return that file names. Okay, the next what we are doing here, files, we are calling this function and assigning this URL, then we will get all file names. And here what we are doing is in the next step we are getting only the files nWidth.avi, which means those are the video files. And here the third one is we are we are uh, printing first 30 value, there's first 30 files. Okay, here we can change this one is 0 to 30. If we want, we can change according to our favorable. Okay, begin with a few videos and limited number of class for training. Begin with a few videos and limited number of classes for training. After running the above code block, notice that the class name is included in the file name of each video. Okay, here if we see this one, uh, file's name, in here we can see that this one is class name. So if we want to take a class name, we can split and get this one. We can say that this is the class, this is the class for this video. So I think here we want to use split function. Okay, we will check. Define the get class function that retrieves the class name from the file name. Then create the function called getFiles by class, which converts the list of all files above into a dictionary listing files for each class. Okay, here we are using def get class function. In here we are passing the file name, and this will return a class name. Here is split this using this underscore. What we will call this? What we'll call the what we call this one underscore, yes, underscore. So if we split using underscore, it will become like this one. Okay, I'll put in some, I will check. Okay, in here we can put it. Okay, if we use a split function, just like this, it will split using a white space and give here. Okay, I will go to this one. Okay, like this one, it will split using white space and give a array. Here if we see welcome is the zeroth index, 2 is the first, there is the, like that. We can print like this one. We want to get the third index, the not the jungle, it will print jungle, I think. Wait, yes, like this one. Here our file name is like this, so we can split using this underscore here. So underscore, then it will split using this underscore and put it to array. So if I want to get the class name, this one is the class name. So to get that one, I can get two things. If we call first index also apply element makeup, or they have another way. From backwards we can see v is a zeroth index, this one is the last one is -1, this one is -2, this one is -3. -3 also printing the same thing. We will check. Okay, -3 also printing, yes, -3 also printing the same one. Like that, here we are split and get -3, so that one is class name. Okay, next what we are doing is get files per class. Okay, now here first we get the class name, and next what we are doing is uh, we are collecting the class name. uh, how I say, like this, we are getting the, yes, we are putting I'll tell like I'm confusing. Okay, retrieve the files that belong to each class. Yes, this one is retrieve the files that belong to each class, which means we will retrieve the files each belong to which class, which means if we take apply makeup. In that they have these all videos come under this one like that. We are putting creating a files by class. Okay, here arguments if file list of files in the data set. Okay, then it will create which class and um, how many videos belong to that class like that. Okay, what we are here we are creating a dictionary default dictionary and class name. We can get class name using this function. So uh, we are getting class names using that function. Files for class. The files for class is the class. Here we are creating a dictionary that's name is files for class and appending file names to that one. Class name is a key here. Okay, it will return the files for class. Once you have the list of files by class, you can choose how many classes you would like to use and how many videos you would like per class in order to create your data set. Okay, here we are creating a two constants. Constant. One is number of classes, how many classes we need, and files page classes. In here, if we see that they have almost 101 categories. So this is 101 classes. Yes, 101 classes. Here we are creating. We will later we will subset those things to train. Otherwise, it will become big training big model. So we will create subset and we will train those things. Okay, what we are doing here, first file for class, get files per class files. Okay, here what we are doing, we are calling this function and we will get classes and uh, what are the videos under those classes. Classes list, what you are doing, classes list files for class dot key. Okay, this is the files for class dot keys. um, it will print the keys. Okay, we'll see here. Yes, files for class dot keys contain how many classes in that one. We will put in that into a list. Here we can just using a len function we can see how many classes is there. So yeah, we see that here we can see that they have 101 classes. I already said no, they have 101 categories, so they are there must be 101 classes. If we see the zeroth class, meaning first class, they have 105 videos. If we change that, okay, wait, I want to run everything again, I think. Otherwise, it will give error. Okay, 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 okay. This one is okay. Have GPU, so I think it not get much time. Here, if we change this to, for example, I change to 10, it will give the 10 files from that zip, like that one, like this one. Okay, here this one is okay, this one is okay. Okay, here we can see that zero class have 145 videos. If we change this one 45, for example, if I get a 45th class, they have 121 videos. So this is a big data set. So we don't need this much. We need to get a subset and we will train that one. Create a new function called select subset of class. that select a subset of the class present within the data set and particular number of files per class. Okay, here what we are doing is we are creating a subset of classes. Okay, files for classes, files per classes. What's this mean? Files for classes, files per classes. Okay, files for class, dictionary of class names, key and value, and files values. Okay, files for class content. That one is a dictionary of class names and values. Class list of classes. Okay, files per class. Name of files per class of interested. Okay, here we are creating a dictionary, and for class name in classes. Okay, here what we are doing, files for class. We are calling the function files for class. Files for class. Which one is files for class? We have a class. No, not function. This one is class name. Okay. Okay, here we are creating. Okay, I will check whether what happening in here using. We will get help from Gemini. What's happening? Is it copied? This function iterate through the list of class. Take a corresponding list of files from files for class and select the first files per class from the list. These selected file then stored in file subset dictionary under the corresponding class name. Okay, it will. Okay, okay, it will create a subset. If we put input some files per class 10, it will get the 10 files in each classes from here to here. Files class. Yeah, here also we want to specify how many classes we want, like that. Okay, here we can see that files subset. Okay, here we are creating subset. Select subset of class. Okay, this function files for class, files for class, files for class, files for class. What is files for class? I think okay. Get files per class. Files for class is all the file classes num classes. Okay, this one is we already, so no, we specify constant. I think 10 classes we are main. Yeah, here number of classes 10, files per class is 50. Okay, 10 classes and files per class is 50. Then we are selecting a 10 classes, and each 10 classes contain 50 videos. Okay, list file subset key. Here this one is print the subset keys mean in the classes are keys in here in this dictionary, so it will print out the classes. Here we can see what are the classes. Okay, I will run this also. Here they have apply eye makeup, apply lipstick, cherry, baby crawling, those 10 categories. We can see they have 10 classes. Defined helper function that split the videos into training, validation, and test set. The videos are downloaded from a URL with a zip file and placed into their respective subdirectories. Okay, zip URL to directory file names. Okay, using this one, we are downloading and copy those things to our directory with rz remote zip URL zip. Okay, zip for F1. This one is for progress bar. What here doing? Class name, get class name. Okay. This one is we already created a function called class name. Using that class name here in every file name we will get the class name. Okay, zip extract fn star to directory class name. Okay, to directory we are to dr. Okay, that one is we want to specify when we call this function. In that class name, here we know we class name is in file name, so we will take that class name and we will put into a subdirectory like that. Unzip file to that unzip file to we are it will like this one which directory, and they have a subfolder class name, and within that they have a file name contains the class name. That's why we are getting that's how we are getting the class name in here. Okay, what's here doing? Fn pathlib paths output file to, okay, the same thing we are doing, and unzip and rename an output file rename. Okay, we will check, we will get the help. Why it's this code downloads from the remote zip file located at zip URL and execute them to local directory to, okay, okay. Sorry. Okay, I think after calling this function it will, okay, we will see now after. Okay, the following function return the remaining data that hasn't already been placed into a subset of folder. It allow you to place that remaining data into next specified subset of data. Files for class count. Return the list of files belong to a subset of data as well as the remainder of files that need to be downloaded. Files for class. Files belonging to particular class of data. Count number of files to download. Return files belong to subset of data. Files belong to the subset of data and dictionary of the remainder of files that need to be downloaded. Amazing. Okay, we'll continue. Split files. This is a array. In Python, we are calling this as a list. No, list. Remainder is a dictionary. Okay, split files. Extend files for class count. In split file, we are extending what are the files we want and how many what are the class we want and how many files. For example, okay, in here I think we want to call classes or classes. What is or class name? I forgotten. In this one is 50. So it will return the split files which contain 50 files, and remainder is other remaining files containing in this remainder. The following download the UCF101 subset function allow you to download a subset of UCF10 dataset and split into a training validation test. You can specify the number of classes that you would like to use. The split document allow you to pass in a dictionary which the key values are the same of key value is the name of the subset, example train, and the number of videos you would like to have per class. Okay, what we are doing here, download use UCF data. Okay, I think we are calling these all three functions. Okay, almost they have all these function and downloading and pre-processing in here. Download a subset of the UCF 101 data and split them into various parts such as training, validation, test, arguments. They have inputs. For when we calling these function, we want to give the some inputs. Those are zip URL. This one is a URL of the zip file. Number of classes. Um, Splits dictionary specifying the training validation set and key division of the value in the number of files per split. Okay. Download directory download to the data. Okay. Mapping of directories containing mapping of directories containing the subsection of data. Okay, wait. This one is okay. And this one. Okay, we'll call this one. Okay, what we are doing here is files. List of files from here we are getting the files and path OS. Remove that item from the list if it does not have a file name. Tokens path split OS sep. What's this one? I have no idea what is this. We will check. This code iterates through a list of file path called file. For each file path f, it performs the following steps. Normalize the path OS path. No pumps f. Converts the file path to standard format, removing redundant separators and solving relative path. Okay. Split into tokens. Split the normalized path into a list of tokens based on the operating path separation. Okay. Check token length. Check if the path has two or few tokens. So this suggests that the path is likely a simple file name without any directory structure. Remove simple file name. If a path has two or fewer tokens, files should remove F removes the corresponding path from the files list. Okay, here if the remove the items from okay here this one is getting the path. Normalize the convert the file path to standard format. Remove the redundant separator. Okay, if they have a redundant separator, it will remove this using this one null path. Now after that, we are tokenizing that one, which means in Windows there's slash like this one forward slash. In Linux and macOS they have I think backslash to separate the directories. So it will slip according to that one. To the check token length. Okay, here I have ambiguous. Checks if the path has two or fewer tokens. This suggests that the path is likely a simple file name without any sorry directory structure. Okay, check if a path has two or fewer tokens. This suggests the path is likely a simple file name without any directory structure. Hmm. Okay. Oh my god. I recorded 34 minutes, man. I can't believe this. so it will become big video. It's okay. We're going to post this one. Okay, if the what's happened here? Tokenize. What happened to check if the path has two of your tokens. I think which have if we have two slice like that, two directory like that. If we have less than two, which mean one. Yes, equal or two. Yeah, that have a parent directory like that. So it will remove. Doesn't contain anything. It will remove like that. Files for class, get files by class. Okay, use get files by class using oh yeah man that function. We first we called that function to get the class names. Yeah, get files by class. Using that we will get classes and files contains files within that class. Okay, classes list files for dot class number of classes files for classes key. Okay, this in this give the all classes in that number of classes, which mean what this get if we put 30, it will give first 30 classes and assign that as a class. Okay, for class in classes shuffle. Okay, shuffling only use the number of classes you want in the dictionary. Okay, files for class x files for class x amount. Okay, I think x is input now. Yeah, x is what is x? X. Okay, we will see. Here we are creating a dictionary. Split count, split items. Okay, what we are doing here is splitting the download directory from download directory split name. Okay, split directory split files for class split class. Okay, this thing is splitting. If we create a function like this, if we can split we will can get training set, validation set and testing set using this class. Okay, here we can download the directory for. Okay, here what is download the UCF data subset URL. Here we can see that one using this one, splitting 30 percentage 10 percentage 10 percentage and we'll download to this path. Okay, we can see that one. Okay, tracking. If I run this will come here. Downloading things. UCF subset file will download it here. Yeah. Should come now here. Okay, we'll see. Yes, it's game. Here we can see that they have other thing. Not this one, sorry. This one. No. Okay, this is the training set. After completing this, they have a validation set, testing set. All those will come. Each contain 10 classes, and each 10 classes have 50 videos. Like that, it will create a subset. Otherwise, we had a large set. Now we are creating a subset. Then we can train using that subset. After downloading the data, you should now have a copy of a subset of UCF data. So run the following code to print the total number of videos we have among the all your subset of data. Okay, what we are doing here, we are just getting the all values in .avi, training and validation testing, and adding those things and printing those things. You can also preview the directory of data files now. Okay, using find this one, we can preview all the files under that directory. They have a training class. In training, they have 10. Oh, okay. They have under each section. They have in training, testing, validation. They have 10 classes. Okay, until it will split. I am pausing my video. Okay, it's splitting, but I will continue other things. Okay, because I already run this, so they have a output file, so we can show that one. Okay, now we created a subset to train. Now we want to pre-process that into an array. I think. Create a frame so each video file. The frames from video file function split the video into frames. Read the randomly chosen span of n frames out of the video file and returns them as a numpy array. To reduce memory and computation overhead, choose a small number of frames. In addition, pick the same number of frames from each video, which makes it easier to work on batches of data. Frames output size. Okay, video is like this. Video contains many photos. That's the video. A video. If we take a video, if it's 60 hertz video, they have a 60 photos in each every second. That if we combine those things, it will become a video. Like that, video is video. Okay, now we will paid and resize an image from a video. Bugs, frames, image that needs to be resized and padding. Output size, pixel size of the output frame image. Return formatted frame with padding or specified output size. Okay, in an optional frame. Here, frame and output size are the arguments, which mean the input of this function. We want to import here frame. Okay, if we call this one, it will return the frame of each video. Okay, but paid and traces image from video. Okay, it will paid all the images and resize all the images within that in a video after the frames from a video file. Okay, create a frame from each video file present for each category. Okay, we will see what's happened. If I have to explain, I will go to Tamil. Frames from file. Okay, file video path, a number of frames, output size, frame step 15. Arguments. Okay, video path final of the name. Okay, number of frames of to be created per video file, output size, pixel size of output frame image. return a number array of frame, the shape of n frame height n. Okay, however, if we are when we are training a model, we need to make an array. Then the array the TensorFlow is training a array type like that. Here we are creating we are converting a video into images and images into array. Then it will we can um, we can train a model. Okay, here what we are doing, creating an array. Capture video capture src video capture video path. Okay, what is happening here? Need length, number of frames. If need length, okay, number of frames now. Okay, yeah, like this. If a video is 30 frames per second, here in each frame step is 15, then in every second it will take a 2 frames, otherwise it will give 30 frames. In according to this function, it will give 2 frames, and we can analyze using those 2 frames. Okay, red is the boolean indicates whether read was successful. Frame is image itself. Okay, wait, call is coming. Okay, we will see how to frame from video file, how to create a frame using a video file. Here what we are doing, red is a boolean indication whether read was successful. Frame is in image itself. Okay, it will check whether image in a video is in image. Sorry, frame. Yes, frame is image. I'm more confusing in this video. Sorry about this one. Studying video is like this. We are getting confused, and after that we can play. Otherwise, in project videos, I will create projects, and after that I will record, and we will like this studying type recording. I will upload. I love to do streaming, but I have only 160 to 170 subscribers, so using 170 streaming is not that much effective. If we get more followers, if subscribers, we will go on live. Okay, visualize video data. The frame from video file function return a set of frames as numpy array. Try using functions on the new video from Wikimedia by. Sorry, it will frames file. The frame video file function that returns set of frames as numpy array. Okay, this frames from video file returns a set of frames as numpy array. Okay, this will return the frames as numpy array. Try using the function on the new frame. Okay, here we are loading total receive average speed, time, current speed. Okay, video path, end game something, end game this one, file, end game this one, or GMV. Okay, we will see sample video frames from video file. Okay, we are calling that function. Video path is this one. 10 frames, 10 frames, sample.video shape. Okay, it will output the shape of the array. Okay, now we convert video file into image and image into array. Okay, to GIF. Okay, now we are convert that into a GIF using this function. Convert images np clip image 255 as type np unit 8 image io mim save im dot gif convert image fps and fps animation gif. Okay, to give sample video, this one is sample video. Okay, we are converting this array into gif using this function. Okay, that to visualization we are creating this function and we'll calling the sample video array, which means the array of endgame gem.ovg it will give the gif. This one I can't, yeah. Okay, this is a gif. In addition to examine this video, you can also display a UCF101 data. To do this, run the following code. Okay, I think now we change video into array. That's the pre-processing. Next, define the frame generator class in order to create a iterable object that can be feed data into TensorFlow data pipeline. The generator call function yield the frame array produced by frames video files and one hot encoder vector of the label associated with the set of frames. Okay, frame generator return a set of frame with their associated label. Okay, this will give a set of frames associated with their labels. Path video file and number of frames, number of training boolean to determine if training data set is being created. Okay, self path test out the frame generator object before wrapping it as a TensorFlow dataset object. Moreover, for training dataset, ensure your label training mode so that the data will be shuffled. Okay, we are labeling the training and testing validation labels. Frame generator subset path training frames training true. Okay, here shape, this is shape, they have 7 labels. Finally, create a TensorFlow data input pipeline. This pipeline that you create from the generator object allow you to feed in data to your deep learning model. In this video pipeline, each element is a single set of frames and its associated label. Create a training set. Okay, output signature, shape, training set. Okay, data from generator. Okay, here we are calling this function tf data dataset f2 what we call input light pipeline. We will using this function getting input pipeline using this function also from generator. Here we are here using that class we will get training subset. Check to see that the labels are shuffled. Okay, for frames label in training dataset dot take 10 print labels. Then we can see that 1763, then it is shuffled. Create a validation set like the previous one training dataset. We are creating here validation. Print the shape of the data. Here just as usual we are printing training frames, uh, training frames and training label shapes, those things. Okay, configure the data set for performance. Okay, I think this also we learned in previous things, no? Using buffer prefetch is such that you can yield data from the disk without having input or become blocking. Two important functions to use file loading. Dataset cache, dataset prefetch. This one is already we learned when we study tf.data. This one is will automatically find out how much buffer size we need. So it will using that we here we are getting input pipeline for training dataset and validation dataset. To prepare the data to be fed into the model, use fetching as shown below. Notice that when working with a video data such as AVI file, the data should be shaped as a 5-dimensional object. These dimensions follow a specified number of frames, height, width, channels. Oh man, they have many things, no? In comparison, an image would have 4 dimensions, batch size, height, dimensions. What is okay? Here, number of frames is more than image. The image below is an illustration of how the shape of the video data is preprocessed. Okay, like this, number of frames, height, width, RGB. Okay, this one is right. Okay, we're creating batches here. Previous also we print the shape now. Yeah, is that same? Okay, after batching, we will get the frame like this. Next step. Okay, I think this is the final step. Now that you have created a TensorFlow dataset of a video frame with their label, you can use it with a deep learning model. The following classification model that uses a pre-trained efficient net trains to high accuracy in the few minutes. Okay, here what we are doing. Hmm. We are getting efficient not pre-trained model, and here first configuring model, and after that comparing and fitting. I think that's all. To learn more about working with data in TensorFlow, check the following tutorials. Okay, that's all. But I think I am also confused little bit when this is the first time I am studying about how to model the videos. So I think I am also confused. But overall, the summary is like this: we are getting a videos, and we will using the video file name. We will create a subsets, and we will put into some subdirectories, and like that we will make a data set. The data set is a biggest one. They have 101 categories, but classes. So after that, we here for trying this, we got 10 classes from that, and each class contains 50 videos. Like that, we trained. Yes, we get the data set like that, and after that, what we're doing, we create video into frames, which mean each photos. Uh, sorry. After that, we convert those images into uh, arrays in like this. Like this. In if we when we preprocess an image, we will get height, width, wedge size, height, width, and channels. But this is the video, so we must need this number of frames. So using the number of frames, we are creating a video like that. When number of frames mean number of photo for each second like that. After that we are creating arrays, and we okay, here in this model first we are rescaling time. I have no idea why it is time distribution. We will see what are these layers in upcoming videos. Okay, we will check what's in here. Okay, sorry guys if it is more, if I trouble more. Sorry, I'm sorry, because this is the first time I am also studying these things. In previous videos we study about text classification, image classification. I already ha- have some familiarities in those things, but video is this is the first time I'm saying video classification. Okay, this one is video classification with 3D convolution neural network. Okay, okay, they have moment. I have doubt what is 3D convolution and 3 plus 1 deconvolution. The answer is here. Okay, we will check those things in upcoming videos. I think this one is confusion matrix. Yes. Okay, keep supporting me guys. Thanks for watching this video. I think it almost was 1 hour. Yes. Bye.